Hello everybody and welcome to my channel. In today's video we're gonna be talking about humanoid simulator and the Fusion to Webots tutorial. This video is supposed to be the final project video submission for my BEng Robotics degree, which is supposed to cover the creation of a humanoid simulator based on a real humanoid from the labs. In the second part of the video, however, I will also be showing a tutorial that I created in getting stuff from Fusion, so the robots that you model in Fusion, directly to Webots without any prior knowledge of how ROS works, how Webots work, or any robotics knowledge. But firstly, we're gonna talk about the project. I will be leaving a timestamp somewhere, either in the description or on the screen, for the tutorial. Right. So the project was created as part of RoboSoc, really, the Robotics Society, part of Plymouth University. Now, 5, I think 6, maybe even more years ago, from 2004 to 2015, University of Plymouth had an official robotics team that was participating in humanoid competitions like RoboCup and FIRA. However, in 2015 the team disbanded, nobody really joined, and for I think 4 or 5 years until 2019 there was pretty much nothing left of the team. In 2019 RoboSoc inherited really the robots, and we started developing on them. Now the robots, when we got them, had no software, just the hardware, and even that was more or less not working. So just the motors, no sensors and all that. Now Scott's Revival, one of the robots that was inherited, would be a great starting point for a humanoids team, because it was started to be developed in 2015, so right before the team disbanded. And for the reason for using a simulator, basically we don't need to have physical access to the robot, and we don't risk breaking very expensive equipment. Everybody knows that with COVID you can't get to the lab, and even if you get to the lab you have to maintain a lot of precautions. Right. Problems encountered during this project would be, well, besides the physical access to the robot for 3D mapping of the entire thing, simulator support and tutorial availability. Basically, when you want to simulate a robot, you have to have a simulator, quite obvious, and the simulators in robotics are a fairly weird are in a fairly weird position, where the industry sometimes doesn't use them at all or uses their own custom simulators, and the ones that are available don't really have a lot of support either on YouTube or from the developers. Now, the project initially was focused on making Scott Robot work, as in actually walking. However, COVID intervened, and the shift of focus happened when I decided that this isn't how hard it's supposed to be. Like, making mechanical modifications to the robot in a simulator shouldn't require you to know all that background stuff about ROS and about how robot kinematics work. So this is why the focus of the current project is to make the entire process of getting into a simulator more streamlined. Also attached to this project will be a paper submitted to Taros 2021, which might be accepted, might not be accepted, that will focus on a comparison between two simulators in particular Coppelia Sim and the Webots. Coppelia Sim was the one that I was advised initially to use, and I have run with it for most of the project. However, I ran into a lot of problems with it when trying to connect it to ROS. As far as work done within the project itself, most of the work was done in mapping this entire robot into Fusion. Since the robot was inherited just with the mechanical parts and no software, we had to create the 3D model based on the real model, not the other way around. Also, lots of research went into how to make the process of mapping the robot and putting it into a simulator much more efficient. As I said, Coppelia Sim importing of the robot as a package from ROS had a lot of issues. A lot of work as part of this project went into going through ROS tutorials, Webots tutorials, Coppelia Sim tutorials, and really the Webots versus Coppelia Sim choice came down to which one has most of the community support, which is Webots in this case, simply because recently they partnered with RoboCup to be the main simulator for use during COVID, because they want to hold the competitions purely online. However, when you actually compare, at least on an undergraduate level, Webots with Coppelia Sim, you will find that Coppelia Sim really is an older type of software that's focused on the kinematics of the robot, and that's what they actually say on their website. They are focused on making the kinematic model work, then just adjusting some physics for the sensors. However, Webots is on the other end of the spectrum, where they have a lot of physical simulation, and this shows in really a lot of spots, like when you model a robot the traditional way, you have to create a kinematic chain. Webots doesn't use the normal kinematic chain like a URDF model, but uses their own proprietary system called protofiles. Now, this protofile doesn't just define the kinematic chain, but also how it is viewed from the physics simulator perspective. So, for example, a single link will be made of the link that is being viewed, so that the one that is being rendered, which is separate from the link that is actually being computed as a collision object. All sorts of small modifications like that. And probably the last reason for choosing Webots, which is really down to preference, is that it's much more streamlined, much more modern. Not just that there are more tutorials, but the buttons are much better adjusted. Known and future uses of this robot would be, well, within RoboSoc firstly. So by using this simulator and this entire design process, we can have the development cycles much faster when we're trying to make modifications to either the control software or the mechanics of the robot. However, because I'm also creating a tutorial, hopefully it will help other people with their projects as well. And now the fun part, a live demonstration of various pieces of my work. By the way, this is a picture from last year, I think in autumn, when Scott finally stood up for the first time ever, and they just powered the motors through the daisy chains directly without using any boards. Right. We had a lot of pictures from the robot. This is back in 2019. I started early on the project, and the way I personally mapped the robot into Fusion was by taking reference pictures with micrometers in the picture and then using them as canvas in Fusion to, to recreate the piece up to scale. And this is how it looks right now in Fusion. This is the final assembly. There have been quite a couple of iterations. And some of them actually got deleted, and there are different iterations for Webots, for Coppelia Sim, and for ROS. However, this is the final one. And let me see if I can find one of the canvases. Okay, not from here. But for example, for the forearm panels, here we have the actual canvas just by taking a picture of a piece of paper where I drew the actual outline with a pen as it was holding onto the robot. You can see the screws popping in from the paper, because we needed very exact measurements of the center of axis for each motor movement. And this is the process through which I went for each of the main pieces. If I'm not mistaken, they are supposed to be carbon fiber. The plain ones, and the other ones are just motors, and this is made out of aluminium. One of the most important things when using this was using the script, going from add-ins and script and add-ins, and here is the URDF exporter. I will link both scripts that I used to streamline the entire process. One of them was used to output directly from Fusion to a URDF file with the meshes, with everything else, and the other one was used within Linux to convert the URDF and the meshes into a final proto file. This is Fusion. Let's see what I can show you in RViz. RViz would be the integrated part of ROS that's supposed to show you with a graphical interface the 3D model. So let's see, if we go to import tester, protos, and the final assembly. Oh, actually this is also part of the Catkin workspace, if I'm not mistaken. Yes, it is. I think this is the name of the file. A couple of warnings simply because the entire script is particularly old, but here it is. So this is the robot within RViz with joint control. And as you can see, I can get the joint controls live. However, I did not put yet any joint limits in it. So this would be RViz. For URDF conversion, let me see the command. Oh dear, it's slowly dying away. So if we go to URDFs, yeah, we can convert the sacro files that the script exports naturally to URDF file, which is the only one that can really be imported in Coppelia Sim in particular. And there it is. So if we type ls, yeah, there we go, model.urdf. The proto converter script, let's see if we can find it. Well, that's really gonna be part of the tutorial as well, so no need to show it here. And really that's about all I wanted to show for here, except for some functionality of Webots, which Coppelia Sim either doesn't have or it's really hard to use. This is currently the robot with a very simple controller that I created, and this is live rendered. In order to modify the controller and make it execute again, I can simply save it, build it, and the entire system will reset. So for example, if I click on, let's say I modify something here, I'm gonna save it, build it, it's gonna ask me if I want to reset the entire world, and it's gonna execute it again. And this is within real time, but it can be sped up quite a bit. So for example, this is the same simulation being sped up. Webots can be used for much more. I simply didn't have the time within the project to get it to work even more. For example, it can be used to render live camera feedback without using an actual camera. And it does have a heck of a lot of tutorials. For example, this is Spot Mini. And this is with live camera feedback. So let's see if we can... Yep, there we go. So this is with live feedback of Spot Mini, and they also have simulators of drones, simulators of epoch, simulators of everything, including tutorials on how to connect it with ROS. Let's see if we can actually get it to work with ROS right now. So if we go to robots, probably somewhere in here. Okay, so I don't really remember where it is. It's within one of the tutorials anyway. Right, this is pretty much my project currently. And now we can start work on the actual tutorial. So I'm gonna reset everything. Right, so for the tutorial, the basic idea is to be able to get something from Fusion all the way to Webots, to a nice simulation without having to write manually the scripts describing every single kinematic piece of the robot. Because technically you're already doing this in Fusion with drag and drop and other options, so there shouldn't be any need for you to write manually. This is especially important in humanoids simply because, well, right here I have 20 links, like easily. Technically there are about 50 components in here, but only 18 or 20 motors. Right, so this is a very basic model of a humanoid that I created with the joints. What you have to keep in mind with Fusion, with the script that I will be putting in the description, the link, is to have the base link contain all the static pieces connected to the body, and ideally you would have this as the main piece of the robot as the base. You can have it otherwise, but it's simply not recommended. And the Revolut joints need to be all part of the main component file, not part of each component, because they will not be exported with the script. Also, the joints need to be, the body needs to be the master, and the slave component needs to be the first one that you actually click on. So this is going to be the master, and if we're talking about hierarchy of the robots, you have this chain as a hierarchy chain. So this is the child of this, which is the child of this, which is the child of the main body. Now if we wanna export it with the URDF exporter script, okay, we're gonna put it within the tutorial folder, and it should tell us that everything is just fine. Perfect. Right, let's check it out. See if it actually got exported properly. Tutorial description URDF tutorial.sacro. And if we open it with the notepad, we can see here the components as well as the joints. Ideally, you would have both the components and the joints with very specific names so that you can easily remember them, because you will need these names once you actually start programming the robot in Webots. Right. The next step would be to get the entire thing into Ubuntu. I am personally using Ubuntu 18 with ROS Melodic, if I'm not mistaken. Once you create your ROS workspace, why is this not working? There it is. So once you create your ROS workspace, you can put this within Catkin VS if you wanna have a try at getting RViz to work. But for this particular tutorial, that's not needed, so we're just gonna copy it on the desktop. Now that we have it in Ubuntu, we can go ahead and start Webots. And we're gonna use the wizard to create a new project directory. Let's leave it completely blank for now. And this is the basic of the basic, and we have it created somewhere. Oh, there we go. Documents, my project worlds. So if we go to documents, my project within Protos, this is where we have to actually put the tutorial description, or the robot description that we just had. We have to start the terminal, and after you have installed the second script, which I should have right here, we can use this ginormous command to create the proto file. So we're gonna have to navigate to it. Let's see, this was documents, my projects. Documents, my project, Protos, tutorial description within URDF. Right, this is where everything is set. And we're gonna be using that command. You have to make two modifications to it. Number one, you have to set it as using the Sacro file, not the URDF file. There is no need to actually convert it right here. And you need to change the name with the actual name of the file. In our case, it's gonna be tutorial.sacro. It's parsing the mesh, and you should probably check that you have one more link than you have the number of joins. Now we can go back into Webots. We can tap on this little sign here, and it's already prepared for us to import. It should be scaling just fine. However, if you go through a couple of Webots tutorials, even just the basic ones, you'll see how to modify the arena to make it much smaller. And this is how you place it in here. As for a let's save the world. Before simulating anything, you should always save the world, because it does have a tendency to remove all your systematic changes. So for example, if I save this and I have to reset the simulation, it won't save the fact that I put a new robot inside. Let's borrow some code from here. So we're going to be using this code in particular, but if you go through the tutorials, you can just use their code. It's pretty much the same. In order to create a controller for this, we're going to go through Wizard's new robot controller with C++, because personally that's what I prefer. You should probably name it something else other than Webots controller. Then we're just gonna paste in the code, and I do have for sure a Revolut joint called rev2. This is how you connect everything if you're using C++. Now to enable the controller, you can just go to controller here and select something else. We have just created my controller, so let's use that. We should save the controller and build the controller as well, and it's gonna always prompt us if we want to reset or reload the world. And now if we start the simulation, there you have it, the joint that's actually moving. And this is pretty much how you get from Fusion 360 all the way to a simulation, a mechanical and programming simulation in Webots. I hope you've enjoyed, and if you have any questions whatsoever about it, I will be making more videos in the future on this topic, simply because currently online I wasn't able to find any tutorials. If you have any questions, just post them in the comments below and I will try to answer all of them. Thanks for watching, and I will see you next time.